We covered externalities. Now let's cover the second market failure in this class, market power. We will review profit maximization and market power. So let's assume firms attempt to maximize profits. Profit is equal to total revenue minus total cost. Again, this should be a review from Micro 202. Remember, total revenue is equal to price times quantity. Total cost is a function of quantity as well, Q as a function of C. This is often confused in problem sets when we're calculating profit. Profit is not equal to total revenue by itself, it's equal to total revenue minus total cost. Marginal revenue and marginal cost. Marginal revenue is equal to a change in total revenue over a change in output, or the derivative of total revenue with respect to quantity, output. Marginal cost is equal to the additional costs incurred by producing an additional unit of output, or the change in total cost over the change in output, or the derivative of total cost over with respect to quantity or output. To maximize profits, we set marginal revenue equal to marginal cost. In order to maximize profits, a firm should continue to produce as long as the additional revenue from an additional unit of output is greater than the additional cost from an additional unit of output. So we keep producing as long as MR is greater than MC. Profits are maximized by producing the quantity at which the marginal cost of the last unit produced is equal to its marginal revenue. Profit maximizing condition, stop producing where marginal revenue equals marginal cost. In perfectly competitive markets, this is quite simple. Under perfect competition, the marginal revenue is equal to the price. So a price-taking firm's profit is maximized by producing the quantity of output at which the marginal cost of the last unit produced is equal to the market price. So firms are going to produce until demand is equal to marginal cost. Here we have the profit maximization problem for perfectly competitive firms in graph form. We have the marginal cost curve in red, and the price in blue. The price for perfectly competitive firms is equal to the marginal revenue, and the market clearing condition was that firms would produce up until the point that the marginal revenue equals marginal cost, and that's what we see on this graph. Where those two curves intersect, we get Q star and P star. What is market power? Market power is the ability to set prices above marginal costs. So in perfectly competitive markets, we know that firms are producing up until the point where the marginal costs equal price. They have no control over price. But we also know that a firm that has some market power has the ability to manipulate prices, unlike a firm in a perfectly competitive market. Firms are more likely to have market power in concentrated markets. So this is the distinction between a monopoly and a perfectly competitive market. There's some space in between those two extremes. A perfectly competitive market is one with an infinite number of firms. A monopoly is one with one firm. But there's something called an oligopoly, where there's several firms. So somewhere in between one and an infinite number. And the fewer the sellers there are means the market is highly concentrated, meaning that the firms that exist in that market have the potential ability to manipulate prices, or they have some market power. Market power is often used interchangeably with the term monopoly power, but monopoly power usually implies one firm. But in general, it implies earning profits in excess of the competitive level. And monopolist actions influence the market price. A monopoly is a market with a single supplier of a good, only one firm supplying the good. As I just said in the previous slide, this can be relaxed a little bit to the point where we have several firms supplying a good, and that would be an oligopoly. Monopolists know their actions influence the market price. They take this into account when deciding how much to produce. So they know that if they produce less, prices will go up, but they also know that they're going to sell less at a given price. So they have to figure out that sweet spot where they're producing less, but prices are going up to the point where their revenues continue to increase. And so that we know that that condition is going to be they'll produce until their marginal revenue equals their marginal cost. They face a downward sloping demand curve, and they're still profit maximized by producing where marginal revenue equals marginal cost. Monopoly and marginal revenue. For price takers, perfect competition, marginal revenue equals price. We saw that on the graph several slides ago. Monopolists face a downward sloping market demand curve. If the monopolist alters its quantity produced, the market price will change. Therefore, marginal revenue will not equal price. That's what we said on the previous slide. How do we find the monopolist's marginal revenue curve? In this course, we'll usually work with linear demand curves. This makes it easy to find the marginal revenue curve. These are demand curves of the form P equals A minus BQ, where A and B are constants. For example, P equals 43 minus 2Q, where P is price and Q is quantity. For a monopolist facing a linear demand curve, the marginal revenue is twice as steep as the demand curve. So if demand is P equals 15 minus 1/3 Q, then marginal revenue is 15 minus 2/3 Q. So B is the slope. In this case, the slope is 1/3 in the demand curve and 2/3 in the marginal revenue curve. If demand is P equals 26 minus 4Q, then marginal revenue is 26 minus 8Q. The curve is twice as steep as the marginal revenue curve is twice as steep as the demand curve. Why does this relationship hold? The marginal revenue is the derivative of total revenue. Recall, marginal revenue equals the change in total revenue over change in output, or the derivative of TR, total revenue, over or with respect to quantity. So we can show this. Suppose the inverse demand curve is P equals A minus BQ, then the monopolist's total revenue is P times Q, which equals A minus BQ times Q. We'll distribute the Q through, so we get AQ minus BQ squared. Marginal revenue, again, is the derivative of that equation with respect to Q, which gives us A minus 2BQ. So it looks just like the demand curve, except with a slope that's twice as steep, 2 times BQ. Here's what it looks like in graph form. The demand curve again is in blue, the marginal cost curve is in red, marginal revenue is in green. So marginal revenue should be twice as steep as the demand curve. In a perfectly competitive market, we would have firms setting marginal cost equal to demand, and we would have Q star and P star at the intersection of the demand and marginal cost curve. But here we're dealing with a monopolist, and so they're setting marginal revenue equal to marginal cost, which means that Q star is where it's labeled there, where at the intersection of marginal revenue and marginal cost, and we draw up to the demand curve to get the price for the monopolist. Why does market power lead to deadweight loss? Well, the efficient allocation is where marginal social benefit equals marginal social cost. What is marginal social benefit and what is marginal social cost? Well, marginal social benefit in this case is just demand because there's no positive externalities. What is the marginal social cost? Well, in this case, we don't have an externality drawn on this graph, so we can consider the marginal social cost to be the private marginal cost curve and the marginal cost curve in red here. So the efficient allocation would be the intersection of the marginal cost and demand curve, or a regular market outcome, but that's not where we are. We're at, because this is a monopolist market, we're producing at Q star, the intersection of the marginal revenue curve and the marginal cost curve. So prices are too high, quantity is too low relative to the efficient outcome, which leads to deadweight loss. How does the government deal with market power, monopoly power? We have antitrust laws that limit market power. U.S. antitrust laws are designed to limit market power. They regulate pricing, mergers, and vertical relationships. Antitrust laws do not prohibit monopolies, but they often prohibit activities that could lead to acquisition or exercise or an exercise of monopoly power. They're enforced by the Department of Justice and the Federal Trade Commission, and all large mergers must be approved by the antitrust authorities. A great example of monopoly power is electricity generation. It has to do with economies of scale. It's a lot cheaper to build a coal plant that has 1,000 megawatt capacity versus 10 coal plants that each have 100 megawatt capacity. So the government allows for this to happen through these antitrust laws because they know it's cheaper to do so and it benefits consumers, but it's still heavily regulated. So you're going to be asked to read an Economist article on market power and markups. The reason I'm asking you to read this is because it gives you a sense of how economists think about market power and measuring market power. One way to measure market power is markups, and they're defined as prices minus marginal cost over marginal cost. So in a perfectly competitive market, prices would be equal to marginal cost, and this measure would be 0. But as market power increases, the price increases over marginal cost, and so this measure increases. It becomes positive. The authors find that the markups have been increasing over time, over the time period that they've studied. Is this necessarily a bad thing for consumers? Not necessarily, because they give you several reasons why this could be a bad thing or might not be a bad thing for consumers. Would you expect globalization to lead to higher or lower markups? Well, competition usually decreases market power, which should decrease markups, and so globalization should probably lead to lower markups. Do markups imply market power? Not necessarily. An increase in markups need not imply an increase in monopoly power. It may reflect an increase in the size of fixed costs relative to variable costs. So this quotation comes from an article by DeLocker and Eekhout from 2017. They say, consider, for example, high-tech firms that produce software products that need one big upfront investment and can be scaled nearly without any additional costs. Such technologies change will lead to higher markups due to lower variable costs, but prices will not drop because firms need to generate revenue to cover fixed costs. So what does this mean? So if you're a software producer, you need to hire software engineers to write the software, which costs a lot of money. You have to pay their salaries, you have to pay their health insurance, etc. So there's upfront costs associated, or fixed costs associated with producing this software. But creating copies of the software, the marginal cost of producing an additional unit of this software is essentially free. It's just copying and pasting the software. And so the variable costs or the marginal costs are basically 0, but the fixed costs are somewhat high. And so in this case, we could see a situation where prices are above marginal cost, but not because of market power, but because of higher fixed costs. However, these authors find no evidence of this in the markets that they look at, and they find that profits increased at an even faster rate than markups over the time period that they looked at.